So this is the today's agenda. Today we are going to enter into a new topic altogether, that is Naviwares part one. Okay, because there are two dedicated classes for Naviwares, so I'm going to discuss the part one today, and the next class we'll see the part two. Okay, so as part of today's class, we are going to see just a quick recap of the last class, whatever we have done. So as part of the revision, then we'll see conditional probability and its a intuition. Then different business use cases I will try to solve, almost 4 to 5 business use cases, like how to find out the next what, obviously by using the deep learning technique I'll show you. Then Swiggy Zomato use cases, Cappuccino Espresso use cases. I will give a classification problem statement. For example, it's a mail spam or not spam. Okay, that also will try to solve by using conditional probability, not by using the machine learning algorithm like classification algorithm. Okay, then positive digits use cases we'll see. Then I will give a clear cut idea. Maybe in the in the previous like intermediate, or maybe in the 10th class you might have gone through probability and statistics. At that time maybe you have some knowledge about the probability, but today we are going to see about conditional probability. So how conditional probability is different from probability, that we'll see. So a difference between probability and the conditional probability. I will give a problem statement. In that problem statement, I will try to solve two different problems. One is related to probability, simple probability. Another is related to conditional probability. So by seeing that question, you will get a difference. You will get a clear cut understanding what is the difference between probability and conditional probability. And as part of that, I will solve two different use cases: Amazon ad use cases as well as LinkedIn Twitter use cases. Okay, then we'll enter into Bayes theorem. What is Bayes theorem and all we'll see. So just for your knowledge sake, so Bayes is nothing but the full form of Bayes is Navier Bayes, basically, as I'm giving the heading subject line. So he's a famous mathematician, as he has developed a beautiful theorem to solve the conditional probability. Based upon his name, we call that theorem as a Bayes theorem. Okay. Then we'll see a cricket match use cases. Then, for example, a funny incident, like for example, a person went to an interview without studying Bayes theorem. What will happen with him or her? Okay, that we'll see. Then Navi Bayes with one feature, comprehension. Then conditional independent in Navi Bayes and okay, disappearing Navi Bayes. So these are the things we'll discuss as part of today's agenda. Okay. So without any delay, let me start with the first one. So first one is nothing but that is revision. Okay. So what we have discussed as part of last class. Let me give a quick recap. So if you have not remembered, so last class we have discussed extensively about the confusion matrix, because it is a long gap, right? Your semester exam was there, so I think 1 week gap, right? After that we are starting, so that's why maybe you forget. So let me give a quick recap. Confusion matrices. So as part of that, we have seen different important parameter like precision, recall, then F1 score. Not only these three, way beyond the precision, recall, F1 score, that is accuracy. Then we have seen sensitivity. We have seen specificity. Then we have seen TPR, true positive rate. Then we have seen FPR, false positive rate. Yes, correct. And we have also derived in the last class this recall, sensitivity, and TPR both are the same. Okay, TPR, true positive rate, sensitivity, and recall both are same. Right? Now, after confusion matrix, we have entered into another beautiful concept, that is ROC core. Then we have seen ROC, AUC score. Then based upon this AUC score, we'll decide whether that particular model is a perfect model versus a random model, right? Able to recall? Let me quickly open the last class, handwritten notes what I have covered, right? So these are the things we have covered in the last class, right? So yeah, telecom churn analysis we have seen. The coming to concept, we have seen this thing, right? So picture elimination, okay, that's fine. So let me go to the actual things. Yeah, BIF, okay, these things also we have covered. Yeah. So confusion matrix, accuracy, we have derived precision, recall, F1 score, accuracy, then sensitivity, specificity, then ROC core, okay, then ROC AUC score, right? Then perfect model versus random model, correct? So these are the things we have covered as part of last class. Clear, guys? Able to remember? Able to recall? And let's come back to our today's class, right? Now, and let's enter into the next one, that is conditional probability. Okay, and obviously we'll go one by one the business use cases and all. So, guys, what do you mean by conditional probability? CONDI, condition, conditional probability. What is conditional probability? You might have seen, no, the probability before. Like as I told you, probability statistics generally we cover maybe your intermediate or maybe high school, right? School and all. But today it is a little bit advanced. Even if we have covered somehow, but this is a little bit in depth. We'll go. I'll try to solve almost different type of problem statement, almost 10 different problem statement. Okay, even if including next class also, right? So, as you know, for example, I'll tell you percentage. Let's say 80 percentage. What do you mean by 80 percentage? Means out of 100, let's say I'll tell Harish secure 80 percentage mark in math. That means out of 100, Harish secure 80. Correct? If my total mark is 100, then Harish secure 80. Correct? Let's say I'll tell, let's say Hari or maybe Shyam secure 75 percentage in physics. It means out of 100, okay, Shyam secures 75 marks. So whenever I'm telling percentage, it is out of 100. Yes or no? Out of 100. Similarly, whenever I'm talking about probability, okay, probability, so it is always in the range of 0 to 1. It never exceed 1. That is the first thumb rule. For example, I'll tell probability of tossing the coin coming here. So definitely the value should be in between 0 and 1. It may be 0, maybe 0.5, maybe 0.25, maybe 0.78, maybe 0.94, whatever it may be, maybe 1. But it cannot say probability of something is 1.15. No, this is wrong. Absolute. And it cannot be negative value also. You cannot tell, okay, let's say 0.25, this is minus 0.25. No, this is also wrong. Cannot be negative value, cannot be exceed more than 1. But coming to percentage, always it will be in between 0 and 100. Yes or no? Percentage. Clear, guys? Any doubts so far? Now, whenever I'm telling this is the probability, right? Simply if I have to find the probability, that's fine. Conditional probability means I have to find out the probability based upon certain condition, and that condition will be given. What type of condition and all that we'll see, that we'll get to know by seeing a problem statement. Okay, till that time, just hold on your excitement. Fine. So, guys, any doubt so far? Any doubt so far? This is called conditional probability. Yeah, you can see. So these are the things I have already explained in the whiteboard. No need to spend much time. You can see precision recall, ROC, AC core, everything we have seen, right? Fine. Now coming to conditional probability. To understand Bayes theorem, it's crucial to first grasp the concept of conditional probability. Conditional probability refers to the likelihood of one event occurring given that another event has already occurred. To gain a better intuition of conditional probability, let's consider scenarios such as tossing a coin and determining the probability of getting either head or tail, or determining the probability of children playing outside when it's raining or when the weather is clear. Okay. So if you see this problem statement, I'm giving certain condition. Generally, every day children may play. That's fine. But I'm asking, trying to find out the probability of children playing outside when it is raining. I'm giving a condition. Or maybe try to find the probability of children playing outside when the weather is clear, means it's not raining. So based upon that condition only, you have to find out conditional probability. Yeah, you have to find the probability against. Okay. In addition, let's also discuss the term prior and posterior probability in the relation to conditional probability. We can use a simple example to illustrate this concept and explore how posterior probability is more informed than prior probability. This concept serves as the foundation for understanding the Navier-Bayes algorithm altogether. Okay, fine. Now, I am going to solve one problem statement. Okay, so first problem statement, let me come back to my whiteboard. I'll explain there. Then rest of the problem statement for the save the time, I will explain directly in the PPT itself. Okay. Now let's come back to the whiteboard and I will try to explain there itself. Fine. Guys, are you able to see here what is happening? You might have seen maybe in the WhatsApp or Google search, Telegram. Whenever you are writing certain word, let's say how are, after that you will see lot of suggestion. Automatically word will come. Even in the WhatsApp chat also. If you will not observe, just type, open your WhatsApp and type something to a friend. You will see auto suggestion. That is called auto completion or auto suggestion technique. Obviously, I mean behind the scene, deep learning algorithm is working. In deep learning, especially the natural language processing (NLP) is working. Okay, we will not go up to that certain level, but I'm trying to explain the concept how it's working. For example, I'm typing how are. Generally, people asking, they are using the word called how are you, or maybe how are the things, or maybe how are the. So you can see there are different words is suggesting. For simplicity, I'm taking only three words, but don't think that only these three words it will suggest many words. Now, you can see, for example, X1, the first word is nothing but my how. That is X1, first one. X2 is nothing but my second word, is nothing but R. Now, X3 is nothing but my third word. Third word is nothing but out of these more words, auto suggestion word, I have to pick any one. Now, given that X1 is how, X2 is equal to R. Now, X3 for all the word. X3 I need to find out. Now, what is the question is, what is the probability of X3 is equal to the, means out of these three words, the word will pick provided this pipeline is a danda mark. Generally, we call it as provided. Okay, you should not call. I mean, how you have to pronounce or how you have to call. That I'm telling you. X1 is equal to how and X2 is equal to R. You should not call okay probability of X3 is equal to the then pipeline symbol. Generally, we call it a pipeline symbol, right? In CSV file, comma separated value, pipeline symbol or a danda mark, right? X1 is equal to how and X2 is equal to R. No, you have to call probability of X3 is equal to the provided. or given by or provided x1 is equal to how and x2 is equal to r. Now you can see now how is nothing but by x1, r is nothing but by x2. Now next one, either I'll choose you or things or we or the whatever maybe. That depends upon obviously as I told you behind the scene NLP, natural language processing is used. It's a part of deep learning technique altogether. Now, based upon that probability, conditional probability to try to pick, because whose conditional probability is more for you word or for these things word or we or the higher the conditional probability, that word will become. Getting my point? And that is happening by using NLP only. So that's how the auto suggestion or auto completion is happening either in the Google search or WhatsApp messages or in any other things, like wherever you are seeing the auto suggestion is happening actually. Okay, clear guys? Any doubts so far? Any doubts so far? Now let's move to the Suki Zomato use case. Okay, fine. So for that, let me come back to my whiteboard. I'll again I'm repeating. This is Swiggy Zomato business use cases. It's a real-time use cases. Okay. Generally, when you join, let's say Swiggy or Zomato, like startup or like Amazon, such type of problem statement, you will try to solve as a data scientist or data engineer and all, machine learning engineer and all, not data engineer, sorry, machine learning engineer and all. So it is giving a problem statement saying that 60% of the people uses Swiggy. Okay, fine. 50% of the people are using Zomato. 20% of the people uses both Swiggy and Zomato. Now it's asking among those who uses Zomato, I mean basically you have to find out the probability. Find the probability among those who uses Zomato, what fraction of people use Swiggy. Okay, let's try to see how I'm solving. In today's class or from today's class, you have to just learn one thing from me. How from this problem statement I'm framing the diagram. That's why I'm solving almost 6 to 7 different problem statement or use cases in today's class itself. That is the act that you have to learn from me in today's class. If you learn, then the rest of the things will be very easy and you'll be master or champion in the conventional probability. If your intention is how Sir is solving by seeing the problem statement, then even though I will solve 1,000 use cases, you will not get anything you cannot solve if I give a new problem statement. So always focus on the concept, what I'm trying to speak and what I'm explaining the whiteboard. Okay. I need your 100% concentration, guys. It's not that much easy, but I make it easy. You feel that, oh, this is nothing. But once you close, you will try to open and see the problem statement, you will be flat. Right? I'm able to understand everything in the classroom, but why I'm not able to solve a problem statement? So focus, give your 100% attention. Okay. From this problem statement, guys, I'm trying to draw a Venn diagram or set diagram. Now try to please help me. Okay, what is telling? Let me take a different color. It's telling 60%. Okay, let me draw. 60% of people are using Swiggy. So this is, let's say Swiggy, I'm writing yes. This is nothing but my 60%. Okay, fantastic. Then it's telling 50% of people are using Zomato. So let's say my Zomato boys is here, Zomato. Z. This is 50%. And 20% of people using both Swiggy and Zomato. So 20% means this much. The common area, right? Intersection part. You see how much? Is telling Swiggy intersection Zomato, right? There is nothing but 20%. 20%. Okay, fantastic. Now, what is the question? Focus on question now. Among those who uses Zomato, who uses Zomato. Now, whenever I'm telling guys Zomato, let me use a different color so that it will be easy for me to call. Think about Swiggy is in a black color circle, Zomato is in a green color circle, right? Fantastic. Now, Who uses Zomato means what? Whenever I'm talking about Zomato, then I have to refer this green color circle, not a black color circle. Why? Because a black color circle represents Swiggy. Correct? What a fraction of people use Swiggy? Are you getting my point? Now, it's telling among those, again I'm repeating, among those, okay, among those, this is a question, among those who uses Zomato. So I got to know Zomato people are using this much, means 50. What a fraction? Fraction means something. Fraction means what in the mathematical terminology? There should be something in the numerator. There should be something in the denominator. Yes or no? So this is numerator. This is denominator. Fraction means some divided, right? For example, I'll tell 1/3 means out of 3 part, 1 part I'm taking. Fraction 1/3. Fraction means divided. Numerator is 1. Denominator is 3. What fraction of people uses Swiggy? So out of this Zomato, what fraction of people uses Swiggy? So when I'm telling Swiggy, so I am focusing on this common part because this common part, only this part also belongs to Swiggy. Yes or no? I cannot say rest of the part belongs to Swiggy. No, rest of the part are purely belongs to Zomato. This white color part you can see, white color part. But only this shadowed part, red color part, belongs to Zomato, but which also again belongs to Swiggy. Are you getting my point? Now, when I'm telling what fraction, no doubt I have to take some numerator value, some denominator value. Now, which I have to take, which part I have to take numerator value, and which part I have to take denominator value, is telling among those who uses Zomato, who is the bigger one, Zomato, this bigger circle. Now, Zomato I will take in the below. That is probability of Zomato. Okay, fantastic. What fraction of people uses Swiggy? Swiggy means who is again in the Zomato, but that is also present in Swiggy. That means probability of Swiggy intersection Zomato. Are you getting my point, guys? Now here you might have seen in a question is giving probability of Swiggy. Think about, I mean, percentage means 60% means 60 divided by 100 is nothing but 0.6, because I told you probability means it should be in between 0 and 1. You cannot say probability is more than 1. That's why you cannot say probability of Swiggy is 60%. No, that is wrong. If you tell that statement, probability of Swiggy is 60, then that is wrong, because probability cannot exceed 1. So probability 0.6. 60 means 60%, means out of 100, how much? Now probability of Zomato is giving 50 percent. 50% means 50 divided by what even a percentage, as I told you, percentage is out of 100, right? So 50 divided by 100, so this is nothing but 0. How much, 2 or what? 0.2, right? Or how much? 5 10.0, sorry, 0.5, right? 1/2 means 0.5. Yeah, 0.5, correct. Now probability of Swiggy intersection Zomato, which is same as probability of a Zomato intersection Swiggy, same, right? Just reverse one. Then nothing but is giving how much? 20%, right? 20%. So 20% means 20 divided by 100. So that is nothing but 1/5. 1/5 means how much? 0.2, I think, right? Now tell me, whenever it's asking from this question, this is the question. Among those who uses Zomato, what fraction of people uses Swiggy? Means it's asking, find the probability of Swiggy provided or given Zomato. Are you getting my point? Probability of what people uses Swiggy means probability of Swiggy provided or given Zomato. This is nothing but probability of Zomato in the denominator, then probability of Swiggy intersection Zomato. So what is the intersection probability of Swiggy and Zomato? Is nothing but 0.2 divided by probability of Zomato is nothing but 0.5, is nothing but 2/5. So 2/5 means how much? I can say, 2 5.0 0.4. 0.4 is probability. If I convert into percentage, then it will be 40%. Yes or no? Yes or no? So this is called conditional probability, because I am not finding out. See, there are two different topics. Anyway, that I'll discuss. I'll cover here in this. Once you cover, you'll get 100% clarity on exactly what is the difference between probability and conditional probability. In one problem statement, I'll try to find out probability of something, then probability of that one by giving something which is conditional probability, then we will get 100% clarity. Just wait for this point. We are here. I'll cover another three problem statement or business use cases, then we'll jump to here. Then as part of this, I'll try to cover two different problem statement. By that time you'll be 100% clear. Okay, don't worry. Okay, so this is nothing but not normal probability, right? This is my conditional probability. In short, I'm writing simply. Okay, conditional probability, because I'm not trying to find out what is the probability of Sugi, tell me, because that is giving already, right? That is giving. Which percentage is giving, I'm getting, right? Probability of Zomato, percentage is giving, I'm getting, fine. But my question is, probability of Sugi given Zomato or provided Zomato, that I'm trying to find out. There's nothing but 0.4, or in percentage if I convert it, then it will be 40%. Guys, any doubt so far? Any doubt so far? Then we'll move to the next problem statement. Anyhow, that I'll show you in my PPT. Let me cover this one. Cappuccino and espresso use cases. Sir, what is this cappuccino and espresso? Basically, I can say the different flavor of coffee bean. You might have seen, right? Cappuccino, espresso, and there are other coffee. In the coffee shop, you'll get a different type of variety or flavor of the coffee, right? These are nothing but this one. We'll try to solve this one. Okay. So let me go back to my PPT. Same things is written here or not? Anything extra? Just have a look, quick look. Swiggy, Zomato, okay. 50%, 60%. Now you can see, yeah. So I'm getting 60%, nothing but probability. Then I'm getting 0.6, 0.5. And Swiggy intersection Zomato is 20%. Nothing but I'm putting all the value, that is getting 2 by 5. Or here you can see, okay, this is different problem statement. So 20 by 50 means 2 by 5 is nothing but 0.4 is nothing but 40%. Yeah, here I written, yeah. 20 by 50, 2 by 5, 0.4, nothing but 40%. Clear? Same things we have done. Fine. Now let's come back to our next problem. Let's see here. What is that? It is known that 80% of people like cappuccino, 40% people like espresso, and 30% like both. Among the people who like cappuccino, what fraction of people like espresso? Okay, try to see how I am deriving this, framing this diagram out of this contextual problem statement. Because if you look at the problem statement, looks like very difficult. It's not possible. But if I draw or frame this diagram, from this you just have to pick the respective data, put into the formula and get the value. That's very simple. Now see, it is telling 80% of people like cappuccino. So I've taken cappuccino C is 80%. I've written here. Fantastic. 40% of people like espresso. Now espresso E I have written 40%. Fantastic. And 30% like both. So the middle part, which I have highlighted in the pink color, that is 30%. It's clear. Now, among the people who like cappuccino, what fraction of people like espresso? It's the same like previous problem statement, because I'm going step by step, little bit in depth. So I'm not trying to switch immediately, otherwise it will go over your head. So I'll correlate to the previous problem statement. I'll make little bit harder and harder. Okay, while showing my different use cases and all. Okay. Now you can see what is the probability of cappuccino as it is giving 80 percentage. Can I tell? 80 divided by 100 is nothing but 0.8. That's the probability of cappuccino. Fantastic. Same like previous one. I have explained. What is the probability of espresso? It is giving 40 percentage. So 40 percentage is nothing but 40 divided by 100. Nothing but 0.4. Clear? Here also I have written here. Percentage is nothing but from 0 to 100. Probability is nothing but 0 to 1. Everything, whatever I am talking, everything I have written. Either in my whiteboard, handwritten notes, or maybe my PPT. Okay? Now, what is the probability of cappuccino intersection espresso? That is 30%, is nothing but 0.3. You can say probability of cappuccino intersection espresso or probability of espresso intersection cappuccino, both are the same. No difference. Now, what is the question? That is very, very important. Among the people who like cappuccino, when I'm telling who like cappuccino means I'm talking about this left and right part. See, here, this part. See for cappuccino. Okay. Not right hand side part. What a fraction, again fraction means divided will come, right? Something will come in the numerator, something will come in the denominator. Fantastic. What fraction of people like espresso means is telling indirectly try to find out the probability of espresso given cappuccino. That's what I've written here. Probability of espresso provided cappuccino or given cappuccino. The formula will be probability of cappuccino intersection espresso divided by the probability of cappuccino. Now tell me what is the probability of cappuccino intersection espresso? Nothing but 0.3. What is the probability of cappuccino only? 0.8. So that nothing but 3 by 8 is nothing but 0.375. What? This is a probability. If I convert into percentage, then it will become 37.5 percentage, right? Because two shift will happen in the right hand side. Clear? Any doubt so far? Any doubt so far? Please let me know. Any doubt so? Clear? Yeah. So we go to the next one. Yeah. This is a little bit trickier and little bit one step, as I told you, little bit one step, little bit complex. I'm going little bit in depth. Okay. Now see. But the question is giving, it's giving, it is known that 30% of the email are spam. Try to read the question first, then I'll try to solve. And 70% are not spam. Not spam means harm, it's good mail. The word purchase occur in 80% of the spam email. It also occur in 10% of the not spam email. Now try to find out overall in what percentage of the email would we see the word purchase. Are you getting my point, guys? Let me explain. What is telling? Let's say you have thousand of mail or maybe 100 mail. Out of 100 mail, 30 mail are spam mail. Spam means not good. It's going to the spam folder. You might have seen in the Google, right? I mean inbox and spam. 7% mail are going to inbox. That means that's good. Now it's telling in that spam email, like 30%, purchase, there is a word called purchase word occur 80% of the spam email. Now it also occurred 10% of the not spam email. Now tell me in overall what percentage that purchase word present in the overall mail itself. So if you read the question, it looks like a bit complex, not that much easy also to solve. Now, what is the act that you have to learn from today's class or from me? How I am deriving or framing this diagram out of this textual context or problem statement. If you learn this act from me or from today's class, then you'll be champion or a master in the Bayes theorem, or I can say conditional probability. Don't try to solve by just looking into the problem statement. You will fact. It's very difficult. Because if you read twice, thrice also, it looks like very difficult. First, you will get the question, means you have to frame a diagram like this. Now, try to understand step by step. I will go how I am framing and bringing this, number out of this context or question. Then rest of the things will be very easy. Put the value in the formula and get the answer. That's all. Nothing else. Not try to. Okay. Okay, guys. So let's think. I'm assuming total 100 mails are there because I'm talking about everything in the context of percentage. So percentage means out of 100 how much, right? Always that is out of 100 how much, correct? Now here, let's think about I have total 100 emails are there. Now out of 100 email is telling 30 percentage of email are spam. So I've written 30 mail are spam. If 30 mail are spam, obviously 100 minus 30, nothing but 70% will be not spam. So I've written 70, not spam. Clear? Till this point, any doubt? First part. Don't look into this. Very simple. Out of 100 mail, 30% is spam, 7% are not spam. So I've written 30 and 70. Fantastic. Now, what is the second? In the second line is written the word purchase occur in 80% of the spam email. Now tell me how many spam email are there? Only 30. 80% of 30 is how much? 80% of 30 is nothing but 24. So out of 30 email, 20 email contains the word called purchase. Then what is the rest of the email? 30 minus 24 is nothing but 6 email does not contain the word called purchase. That's why I've written no purchase word. Clear? Guys, any doubt so far? Any doubt so far for the second line of problem statement? See, each line of problem statement contains this visual diagram. I'm going step by step to make it easy. It's not that much easy, guys. It looks like very easy as I'm explaining. But if you look into books or any, internet, it's not easy to solve a problem statement. Constant problem statement. Okay. Now, but the next part, it is also occur in 10% of not spam email. Means not spam email is 70. 10% of 70 mail contains the word purchase. Means how much? 10% of 70 means 7. So 7 mail contains purchase. Now what is the remaining mail? 70 minus 7 is nothing but 63 email does not contain the purchase word. Are you getting my point? Now, if you calculate overall in what percentage of email would see or contain the word purchase, now here 24, here 7. 24 plus 7 is how much? 31. 31 email contains word called purchase. Out of what? Out of 100 because I'm asking what percentage. Percentage is always calculating on base of 100. Now, same things I'm doing here. 24 what male contents purchase. Here 7 male contents purchase. 27 plus 7 is nothing but 31. Out of 100 is nothing but 31 percentage, or if you find probability, nothing but 0.31 probability. Clear, guys? Any doubt so far? See how things are becoming easy if I find out the actual number. Because if you find out the actual number, put the number into the formula and get the answer. That's all. But challenging thing is how to find out here 24, 6, 7, 6. That you have to understand by reading from problem statement how I am doing step by step. That is the act. Clear, guys? Any doubt so far? Any doubt so far? Now let's move to the next problem statement. It is bit complicated again compared to the previous one. Try to see what is happening here. Let me maximize it. A disease affects 10% of the population. Among those who have the disease, 80% get positive test result. And among those who does not have the disease, 5% get the positive test result. Clear? The question is, I'm not writing the question, I just represent in the mathematical expression so that you will acquainted how I'm representing. Is asking, find out the probability of positive cases provided having disease. Looks like a little bit complex, right? Let me make it very simple. Guys, think about the corona situation. Okay, when corona came, you might have seen Maybe out of 100 people or 1,000 people, all people are not getting affected by corona. The symptom may be showing that they have fever, cold, and all, they are sneezing and all. But still, it's not like that all people having cold or having a corona. No, no. Maybe it affect out of 1,000, maybe 200 people got affected by corona. Means they are assuming we have corona. 80 or 800 people they are assuming we don't have corona. Now, among those who having corona, the 200 people assuming, if they go for undergo for a test, COVID test, 80% people got positive result, test result. Among who have disease, means they're assuming we have disease. Among those who does not have disease, means out of 800 people who are thinking that they don't have disease, if they undergo for test, 5% people get positive result also. Now we have to find out what is the probability of positive, getting positive, having disease, means people who are assuming the disease. Okay, now you can see this is nothing but is giving 80% people who are having disease, 80% get positive result, right? So that is not 80%. Fine. Now try to see how I am framing this diagram out of this problem statement, because that is the thing you have to learn from today's class, nothing else. The rest of the thing you can solve by your own, nothing else. You don't need my help at all. Okay, think about, for simplicity, I have taken total population of the let's say any city or any town is 1,000. So now it's telling a disease affect 10% of the population. So out of 1,000, 10% of the people got affected by disease. So out of 10% of 1,000 is nothing but 100 people. So 100 people having positive disease and disease. So how many people doesn't have disease? 1,000 minus 100 is nothing but 900. So 900 people having no disease. Clear, guys? Any doubts so far? Any doubts so? Clear. Now, among those who have disease, now which is disease section? This one. This is non-disease. That's why it is no D. Non-disease. This is disease D. 80% get positive result. Means 80% of 100. Nothing but 80. Out of 100 people, 80 people find out COVID positive. Now, 100 minus 80 is nothing but 20%. 20 people find out COVID negative. They can enjoy. They are absolutely fine. Free from any danger. So this is fine. Now, third problem statement. Among those who does not have disease, so who does not have disease in this section, 900 people, 5% get positive, means 5% of 900 is nothing but 45. 45 people having positive, who are claiming that they don't have actual COVID, but actually they are COVID. And 900 minus 45 is nothing but 855 people having no corona disease, find out COVID negative. Clear, guys? Any doubts so far? Now, if I find out the positive cases. So positive cases means here finding positive cases 80, here finding positive cases 45. 45 plus, sorry, 80 plus 45. 80 plus 45. Out of what? What is the total population I have achieved? 1,000. Out of 1,000. Nothing but 80 plus 45, nothing but 125. Divided by 1,000, nothing but 12.5. 12.5% people having positive disease. If I find the probability, it will become 0.125. Clear, guys? This is the percentage or probability people having positive cases. Then if I subtract, let's say 100 minus 12.5, it will come around 87.5 people having no corona disease, means COVID negative. Clear, guys? Any doubt so far? Any doubt so far? Now, similarly, you can see here, I've drawn the diagram, same diagram. You can see 100 digits, 900 no digits. So, in the 100 digits, 80 people finding positive. In the 900, only 45 people find positive. So, if I take the intersection like digits and positive, means digits intersection positive is nothing but probability of digits intersection positive, nothing but 80 divided by 1000. Negative and positive. Negative and positive. Sorry, no digits having positive. No digit intersection positive. Okay, no, so probability of no digits intersection positive nothing but 45 divided by 1000. So if you add both the things, it will come the same things whatever is coming, because here 80 divided by 1000 plus 45 divided by 1000 nothing but 80 plus 40 by 125 divided by 1000 nothing but 0 125. So whether you follow this methodology, whether you follow individual methodology and add them up, answer will be the same. So there are two different ways I have shown you to find out the answer of your question. Clear, guys? Any doubt so far? Any doubt so far? Ricky, okay. What is the difference between probability and conditional probability? Okay, I'll take a business use cases and there I will solve. Okay. So for that, I have taken the first one. It's nothing but Amazon ad use cases. Okay. And what is the second one? LinkedIn Twitter use cases. Okay. So there are two problem statements I am taking here. Another one is LinkedIn, Twitter. Use case. Okay, fine. Let's go back to my PPT. Because the question is giving a website has noticed the following statistics. What is that? Among those who saw the ad, 70% saw it on YouTube. Okay, generally they are running an Amazon ad, okay, to bring the customer onto their website so that people will do online shopping or whatever maybe, so that they'll make the profit margin. So they are saying 70% of the people are seeing the ads on YouTube. 50% of the people seeing the ad on website, Amazon website itself, and 35% of the people are seeing both. So if I draw by this time, I think we'll be acquainted with how I'm framing the diagram or the draw the Venn diagram or set diagram, whatever you call it as. Okay. Now there is a survey happening in Amazon. Then let's say think you are joining in Amazon as a data scientist or machine learning engineer. You got this problem statement to solve it. So how to do that? Okay. Now it's telling 70% of people are seeing the ad on YouTube. Now I'm just bringing this a blue color circle. 70% of people see the ad on YouTube. Okay, fantastic. Now I'm drawing this green color circle. 50% of the people seeing on Amazon. So this belongs to Amazon, 50%. Fantastic. Now 35% saw it on both the cases. Now this middle one, the pink color highlighted mark, I make it 35%. Clear, guys? Any doubts so far? So that is nothing but YouTube intersection Amazon. I mean both the people are looking into, right? YouTube intersection Amazon, that is 35%. Fine. Now, what is the question? Question is here, guys. The first question is related to probability. Second question is related to conditional probability. Now try to read the question, these two questions, and try to compare. You'll get to know, you'll get 100% clarity. What is the difference between probability and conditional probability? Here I'm asking, a random person is choosing. Okay. So out of this, I choose a random person. What is the probability that he saw the ad on YouTube? If I'm telling he saw the ad on YouTube, so this blue color circle is belongs to YouTube only. Now this is how much percentage I can say, giving 70 percentage. 70 percentage is nothing but 70 divided by 100 is nothing but 0.7. So the probability, if I pick a person randomly that he saw the ad on YouTube, then nothing but my 0.7. Fantastic. Now look into the second question. A random person. See, the twist in the question. A random person who saw the ad on Amazon is choosing. Are you getting my point? Here, I'm choosing a random person that maybe belongs to here, here, here. I don't know. But in second problem statement, I'm saying a random person who saw the ad on Amazon is choosing. Means I am choosing from this green color circle forcefully because that is my condition I'm giving. That is the condition. That's why it's telling conditional probability. Here normal probability. Here I'm giving the condition. Hey, you have to choose a person. You have to pick a person from this green color circle only. Then only to satisfy my question who saw the ad on Amazon. Fantastic. What is the probability means? Probability means basically what is the fraction or what is the probability that he also saw the ad on YouTube. If I'll take talk about YouTube, then that comes to talk this blue color circle. Now tell me, out of this green color circle, which part belongs to this blue color circle is nothing but this overlap part, this one, highlighted by this pink color area. That means it's asking what is the probability that he saw the ad on YouTube means probability of finding the YouTube provided or given a margin. Now, what is the probability or what is the percentage that he saw the ad on both YouTube and Amazon? Then nothing but 35. This common area. Divided by what is the probability that he saw in Amazon is 50. So 35 divided by 50 is nothing but 0.7. So here, luckily, probability of y given a is equal to probability of y, or you can say probability of y, conditional probability of a, I can say is equal to probability of y. Luckily is matching, but it does not mean every time both the value will be same. Actually, it will be different because here I am trying to find out the probability of y, but here I am trying to find the probability of y given a or provided a. So these two are two different things, not same. So here, luckily value are matching. Maybe some other problem statement value won't match. Generally it won't match. Clear guys? Any doubt so far? Any doubt so far? Now move to the next one. After this we'll take a small break. Nothing to do. In a city, 7% of the people are on the Twitter, 5% of the people are on the LinkedIn, 4% of the people are both LinkedIn and Twitter. Clear? Now, question is given. A random person is choosing. What is the probability that he's on the Twitter? Okay, fine. We'll go one by one. Now tell me. In a city, 7% of the people are on the Twitter. Now it's written Twitter, 7%. Fantastic. 5% of the people are on the LinkedIn. 5% on the LinkedIn. Fantastic. 4% of the people are on both LinkedIn and Twitter. So that is nothing but this area, 4% on both. Getting my point? Now, probability of Twitter, if I find out only probability of Twitter is nothing but 7 divided by 100. Why? Because 7% is given. That nothing but you can see 0.07 probability or 7%. Now, a random person is choosing what is the probability that is your Twitter. This is the answer. Now, second is a random LinkedIn user is choosing. LinkedIn user means this one belongs to this green color area, which is nothing but 5%. Okay. What is the probability that he is on the Twitter? If he should have to belong to Twitter, then I have to take this part, common part. So it's nothing but probability of Twitter given LinkedIn is nothing but 4 this common part divided by this green color part is 5. 4 divided by 5 is nothing but 0.8 is nothing but 80 percentage. So if the final probability nothing but 0.8. This is the value. Okay, here you can see two different things. Here 7%, here 80%. Value are not matching. But in previous cases, luckily the value are matching. But generally, most of the time, the value won't be matched because it's two different things. Here I'm trying to figure it out, probability of Twitter. Here I'm trying to find out probability of Twitter given LinkedIn or provided LinkedIn. So this is two different things, not the same. Clear, guys? Any doubt so far? Any doubt so far? That is Bayes theorem, and I'll solve a problem statement like it can match use cases. Okay, Bayes theorem. Okay. So before jumping into Bayes theorem, obviously my PPT, let me give some introduction part. Then we'll take a small break. We'll come back and I will enter into PPT and we'll see in depth everything. Okay. So guys, what do you mean by Bayes theorem? What do you mean by Bayes? It looks like something a crazy name, right? So generally, there is a famous mathematician. I can say that name is called Navi Bayes. I have written in my subject line of today's class, I think, right here. Navi Bayes. Navi Bayes. He developed a famous algorithm or a theorem, I can say, which we can use to solve the conditional probability problem statement in a very easy manner. As he has developed, so he gave his name is called to that algorithm is called Bayes theorem. So Bayes is nothing but this is a surname, I can say. That's why giving this one called Bayes theorem. This is a famous mathematician. So, how by using Bayes theorem we are solving the problem statement of conditional probability and what are the other things that we'll see once we come back from our break. Okay. So now guys, just take a small break. It is 10 16. Just take 2 3 minutes break. We'll come back and we'll continue from here. Is that fine? So meantime, let me share my PPT also. Just have a look. Okay. So what is Bayes theorem? To calculate conditional probability using Bayes theorem, let's consider an example related to cricket, which most of us can relate to. When watching cricket match on TV, you may have noticed statistics such as, let's say, India wins 70% of matches when Sachin Tendulkar score a century. You might have seen, right? For example, Sachin Tendulkar play in his entire let's say career there's 100 matches, okay, or maybe 200 matches, out of which he has done century maybe in 30 matches. Out of that 30 matches, maybe India win maybe 25 matches and India lose another 5 matches. Okay, so this is a classic example of how conditional probability can be worked to estimate the likelihood of an event occurring given certain other event. What is that? So, for instance, is giving two different problem statement. Suppose that India play 100 matches, okay, won 60 and lose 40. Clear? Now, Sachin played in all 100 matches, fantastic, and score a century in 12 of them. So, out of 100 matches, Sachin make 12 century, and then remaining matches like the 100 minus 12 is nothing but 80 matches. He does not make any century. Fantastic. Now, additionally, we have the following information. What is that? Sachin scored a century in 10 of the 60 games that India won and in only 2 of the 40 games where India lose. Guys, out of these two problem statement, which is mentioned in 4 different lines, I'll try to frame the diagram so that it will be easy for you to visualize and to find out, oh, this is what this problem statement is telling. Because if you read it out, looks like very complex. What is always number, number? Because this is number, 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 again number, here lot of number. Let me frame a diagram and kept in front of you so that you feel very comfortable. Okay, this is what the problem statement is talking all about. Okay, for that, let me come back to my whiteboard. Okay, there are total 100 matches. Okay, 100 matches. Let me use a different color. 100 matches. Out of 100 matches is telling 60 matches India win the match. So let me write India win. Okay. Now, so remaining 100 minus 60 is nothing but 40 matches. No doubt India lose the match. India lose the match. Now it's telling, so whatever the 100 matches got played, in all the 100 matches, uh, Sachin Tendulkar was involved. So Sachin Tendulkar played all the 100 matches. Now out of 60 is telling, according to problem statement, is telling 10 matches Sachin Tendulkar makes century. Sachin Tendulkar makes century 100. That means remaining matches is nothing but 60 minus 10 is nothing but 50 matches where India win, but Sachin Tendulkar does not make a century. So Sachin Tendulkar, no 100, does not make century. Clear? Now similarly, coming to the second part is telling where India lose the matches. In that, in 20 matches, sorry, in 2 matches, Sachin Tendulkar make the century. Sachin Tendulkar makes century. The remaining 40 minus 2 is nothing but 38 matches where India lose it and Sachin Tendulkar does not make century. Clear, guys? This is what is telling in that two different problem statement by writing 4 different lines that I am framing in a beautiful diagram so that by seeing this, happily a person can understand. Total Sachin Tendulkar play totally 100 matches, play 100 matches. Out of 100 matches, 60 matches India win, and obviously remaining 40 matches India lose. Fine. In that 60 matches, Sachin Tendulkar make in 10 matches 100. Remaining 50 matches, he does not make 100. Now, out of 40 matches where India lose it, Sachin Tendulkar also did 100 in 2 matches. Remaining 30 matches, he does not make any 100. Clear, guys? That is what is telling is a conditional probability. Okay, concept based probability problem statement. Okay, let me repeat one more time. I hope you are clear, but let me repeat. So total 100 matches played, right? Out of 100 matches, 60 matches India win the match. Obviously, 100 minus 60 is equal to 40. India lose the match. Out of 60, in 10 matches, Sachin make the score century. So obviously 60 minus 10 is equal to 50, where Sachin does not make a century, does not score a century. Fantastic. Now, the remaining where India lose the match, that is 40. Out of 40, Sachin score a century is 2 number of matches. 40 minus 2 is equal to 38, where Sachin does not score a century, that is 38. If I ask me, what is the total score of century? That is Sachin score a century. 10 plus 2 is equal to 12. So how many matches Sachin does not make a century? That is 50 plus 30 is nothing but 88. Or you can say 100 minus 12 is nothing but 88. That is the entire game of the problem statement that is giving or written in these 4 different lines. Clear, guys? Any doubt so far? I hope now by this time it will be clear, 100%, right? Or still you have any doubt? Please let me. Now let's move to the next one, the Bayes theorem. Generally, what kind of question we ask? So, what is the probability that India will win when Sachin score a century? So Sachin score a century means, and provided is giving that India will win. Okay, India will win means 60. Sachin make a century means 10. So 10 divided by 16 nothing but 1 by 6. So 1 by 6 whatever you come, that is the probability, or you can make it into 100, that is the percentage. Clear? Now what is the other question? To answer the question we will use Bayes theorem and estimate the joint and conditional probability of such a scoring pattern in an India versus let's say Sri Lanka cricket match or South Africa cricket match, whatever it may be. In addition to this, we'll also learn some crucial concept related to Bayes theorem, such as joint probability and conditional probability. Let's reinforce this concept by revisiting the spam ham example we discussed earlier. We'll define event A and B as follows. A, the email is spam. B, the email contains the word Viagra. Similarly, like how I just cover sometimes before break. A email contains word called purchase. Email does not contain the word called purchase. This is same thing, same example, right? So which type of probability is the probability that an email which contains the word Bhegara is a spam? So such type of example we just cover before break only. So these problem statements are comes under conditional probability, and by using Bayes theorem happily we can solve. Now this is a funny incident, guys. I have told you. For example, a person went to the interview without preparing on Bayes theorem or without studying the conditional probability. Then what will happen with him or her? What's the situation? This is a funny picture I'm showing you. He or she went to interview without studying Bayes theorem. Then what happens to him? Now you can see the picture. I don't need to speak. This is what is happening to him. Okay, this is a funny diagram, but I don't need to speak. I don't need to explain. By seeing the diagram, you'll get to know. That means directly or indirectly, I am to tell you it is that much important. Whenever you are going for any data scientist or machine learning interview start from probability and statistics onwards. First question they will ask, okay, tell me what is Bayes theorem? Why we use Bayes theorem? Where we use Bayes theorem? What is conditional probability and all? So this is that much important. That means without preparing Bayes theorem or conditional probability, don't enter into any interview room which is based upon data scientist profile or machine learning profile or whatever. Man. This is that much important. Guys, any doubt so far? Any doubt so far? Now the next one. This is the formula of Bayes theorem. As I told you, Bayes. Generally, the name is called Bayes theorem. Generally, people are called Bayes, B-A-E, Bayes theorem. Bayes theorem or Bayes theorem. So it's telling posterior probability. Probability of A giving B is nothing but the formula is probability of B giving A, just opposite one, into probability of A divided by probability of B. Clear? Similarly, giving the another thing. Probability of chill giving Netflix is called the probability of Netflix giving chill into probability of chill divided by probability of matrix. Clear, guys? Any doubts so far? Any doubts so far? Now let's come back to my whiteboard. Let's see what is present in the next. Yeah. Okay. So we have covered what will happen if we enter into interview without studying Bayes theorem. Okay. Now we are going to enter into Nabi Bayes with one feature. So I will take with one feature, then I will exceed with the two feature, then with multiple feature. Obviously, it will become complex slowly. That's why I'm starting with one feature. Feature means you know, right? Generally, whenever I want to find out the target variable, as we have already discussed, we have something called feature, we have a target. So here only one feature I'm taking. Okay. Nabi Bayes with one feature. Sorry. Let me change the color. Yeah, I'll cover this thing also simultaneously. Let me go back to my PPT. Fine. The Navier-Bayes algorithm employs Bayes theorem to classify new text point into either of the two categories, edible or poisonous. Bayes theorem is a probabilistic classifier that computes the probability of a text point belongs to the category. So what is happening, guys? Here, generally, I've taken the problem statement. Uh, yeah. The formula I'm showing probability of finding. So CI denotes the classes, provided X denotes the feature of the data point. Is nothing but probability of X given CI into probability of CI divided by probability of X. Is nothing but this formula. I've told you, right? This one. This formula is written. The terms of CI and X. Fine. For categorical data, probabilistic are computed by counting the number of instances or occurrences. The denominator, that is P of X effect, is not considered when calculating the probability because it is the same for both classes and can be ignored without impacting the final outcome. The assignment class for the new test point is the category for which probability of Ci given X is greater. You can see the problem statement here. You can see similar type of data set while downloading from the platform. So basically, there is a serial number. That's fine, not an issue, not a big deal for me. My important feature is a type of mushroom, either poisonous or edible. Edible is good, not poisonous. Shape of the mushroom, you might have seen. There are two different mushroom coming, available in the market, like bottom shape, like kind of bell shape. Another one is convex shape. Convex is a bigger one, little bit bigger one. This looks like convex shape and all. Okay, clear. So this is convex shape or bell shape, editable or poisonous. This is data set is giving. So what I'm doing with this, so comprehension. I'm trying to figure it out some extra thing out of this data set. In the given data set, there are 12 mushroom category are either edible or poisonous based upon their cap set. So cap set is nothing but here, either convex or bell shape like this one, bottom set. The goal is to train a Navier-Bayes model to predict the probability of a given mushroom being edible or poisonous based on its capsid. The class label are represented as C1 for edible and C2 for poisonous. the probability of mushroom being edible is found to be 66.66%. Why? Because if you see, if you're counting, so edible, the percentage is a little bit more. So you can say 1, 2, 3, 4, 5, 6, 7, 8. So out of total 12 record, 8 are related to edible. So if you figure it out, 8 means that is nothing but 66.66%. Using Bayes theorem, the probability of a mushroom being either edible or poisonous based on its cap shape is calculated also. It can be because this is a middle one, intersection part. For instances, for a mushroom with a convex cap shape, the probability of it being edible or poisonous is 50% each. Because if you're still counting, if you see, let's say one convex, one, two, three, 4, 5, 6. Obviously 7, 8, and this is bell. But if you try to see, let's say edible and poisonous, right? This is what is telling. A mushroom with a convex cap shape, the probability of being edible, right? Convex and edible. So here convex, not edible. Here convex, edible. One, two, three. Then this is not acceptable. Four and four. So four means obviously is no. We have so this is one edible. One, two, three, 4. And the opposite one is nothing but, let's say, poisonous. One, 2, 3, and this is also 4. So total 4 poisonous plus convex, another 4 edible plus convex. So as it is a balance, so that's why it's telling 50% of each. Okay. Now, what is happening? The probability are calculated based upon the cap shape and the corresponding likelihood of that cap shape for the given classes. Clear, guys? So I'm trying to find out the value from that dataset. The denominator of the expression remains constant for both classes and hence can be ignored because both the denominator same. So you can ignore only the numerator part you have to calculate. Comparing the numerator of both the classes, a convex mushroom cannot be classified as either edible or poisonous since both have equal probability. That is 4 by 12 because as I told you, right? 4. Out of what? Total is 12. 12 records are there. So 4 by 12 is nothing but 33.33%. So the P probability that govern the result. What is that? Probability of edible only, comma, probability of convex given edible and probability of convex given poisonous. So this is for obviously probability edible, obviously what that is for. The abundance of edible mushroom and their likelihood of having a convex cap shape make the probability of a convex mushroom being edible higher than the poisonous. However, since all poisonous mushrooms in the dataset have a convex cap shape, the probability of a convex mushroom being poisonous is also significant. Okay, that is very very important. Now you can see here I have added one more extra column, that is cap surface, either smoothie or scaly, because here in my previous problem statement, only two columns are there. Type of mushroom, cap shape. Forget about the serial number. That is not a number, right? To count how many records are there. So here two columns are there. I have added one more extra column here. That is called cap surface. Now I have three columns are there. That is either scaly or smooth or fibrous also. Yeah, either fibrous or smooth or scaly. Okay. Clear? Now what is happening here? There, I'm playing around only one feature. Here, I'm playing around two different features. Convex with scaly. So, taking care of cap shape along with the cap surface. Initially, I'm taking care of only cap shape. Then I'm finding out type of mushroom like poisonous or edible, which is significant, more significant, either poisonous or edible. But here, I'm taking combination of both capsule and cap surface. That may be convex scally, convex smoothie, or Bell scally, Bell smoothie, or convex fibrous, bell fibrous, whatever. All the permutation combination I'm taking there. Okay. Now you can see if you calculate that one, it's coming like this. The first two column are the same attribute as discussed earlier. The third column is the newly added column, that is cap surface, as I told you. The goal is to predict the type of mushroom based upon these two features. In the multivariate case, the feature x is represented as x is equal to cap shape and cap surface because I'm taking combination of two different features. Let's assume you have a mushroom with cap shape is equal to convex and a cap surface is scaly, and you want to calculate the probability of being edible, which is expressed as probability of edible given convex and scaly is equal to probability of convex and scaly giving edible into probability of edible divided by probability of convex and scaly. Because the formula is same. This formula is same as the Bayes original formula. This one, probability of A given B is nothing but probability of B given A, just opposite one, into probability of A, that is the top one, first one, divided by probability of B. That is what I am doing here. See, probability of edible given convex and scaly. Think about this is one term. Then is equal to probability of the second term, convex and scaly, given edible into probability of edible, the first one, whole divided by probability of second part, convex and scaly. Getting my point? That is what is written in the Bayes theorem, that is formula, original formula. Now, similarly, you can derive the expression for probability of poisonous given convex and scaly and compare it with the probability of edible given convex and scaly to draw a conclusion. Note that you don't need to calculate the demonstration denominator. Why? Because it is same for both edible and poisonous mushroom. Okay, if the denominator are same, then you don't need to calculate to make it more complex altogether. Clear, guys? Any doubt so far? Any doubt? Yeah. So we will try to find out according to Bayes formula, the probability of A giving B is equal to probability of B given A, just opposite one, into probability of A whole divided by probability of that. This is the formula according to the Bayes theorem. This formula we are using and we are calculating nothing else, not a rocket science, nothing else. This is according to single one. Example, single feature, okay, fantastic, happily you can get it. Let me write down for two feature. If two feature, for example, according to our problem statement, what I have written here actually, probability of, okay, probability of, let's say, edible given, let's say, convex comma what else, let's say scaly, or let's say smooth, 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 okay, smooth is equal to probability of convex comma smooth given edible into probability of edible. Now try to compare with the above one so that we will get getting much clarity. Let me scroll up. Huh. Okay, let me scroll up a little bit. Yeah, then probability of convex comma smooth. That is what is written in the PPT. Maybe there you will getting confused, but here you will get 100% clarity. See, try to compare. Both are same or not? Just I'm putting in a different formula altogether. Think about only one thing. Assume. Think about this B term. This B term is same as, sorry, this B term, this B is same as combination of both convex and smooth. So what is happening? Probability A given B is nothing but probability of B given A. So that is nothing but probability of convex comma smooth given edible into probability A, nothing but the first is coming. So that is probability of edible divided by probability B, the second part, nothing but probability of convex comma smooth. That is what is written. So similarly, so tomorrow, if somebody asks, could you please tell me what is the probability of poisonous, POI poison, poisonous giving, let's say, instead of convex, what is the other one? It was like convex, another the Bell cell, right? Let's say Bell giving, let's say fibrous or what is the scaly is equal to, very simple, probability of Bell comma scaly provided poisonous into probability of poisonous probability poisonous divided by probability of Bell and scaly. Clear, guys? Any doubts so far? So you can derive any formula if your concept is clear on the base formula itself. So base formula is nothing but, that's why it's telling Bayes theorem or base theorem, right? Bayes formula. That is base formula, right? Generally, base, general base means BAC, base. We call it a base, BAE, BYE, BAE. Okay, base theorem, Bayes theorem. Okay, fine. So actual name is Bayes theorem. Fine, clear, guys? The next one, let's see. Yeah. The conditional independent in navigation and dispersion. This thing will cover and this will successfully complete. So conditional independent in navigation. So let me go directly and will explain. Okay. In short, I'm writing conditional probability with navigation. Okay. Let me go to my PPT. So conditional independent in navigation. Okay. Not a conditional probability, but conditional independent. Okay, fine. Yeah. So let me go back to my PPT. Yeah, you can see. Conditional independent navigation. The classification problem can be easily solved in cases where the probability can be calculated by counting, as is the case with navigation. Understanding how navigation work become more apparent when there are multiple features in the dataset. To gain a better understanding of the concept of conditional independent, download the mushroom data subset provided on the platform and consider the scenario of the determining whether a mushroom is edible or poisonous. The navigators make the assumption that variables are conditionally independent given the classes. For example, you can see trying to find out probability of convex comma smooth given variable can be expressed as probability of smooth given edible into probability of convex given edible. So that is also kind of a simplification of giving this formula, because I'm trying to simplify it. Probability of convex comma smooth given edible. Can I write probability of convex giving edible into probability of smooth giving edible? That's what is written, right? Can we express our probability of smooth giving edible, the probability of convex giving edible? That's all. Just simplification purpose. That's all. These probabilities can be expressed as can be easily calculated by counting the data point. How? This is why the algorithm referred as a Navi bias, as it assumes that variables are not conditionally independent in most real-world situations. However, the algorithm still performs well in many cases. If you are trying to calculate probability of A and B given C, and probability of A given C is the same for all values of B, and probability of B given C is the same for all values of A, then A and B are conditionally independent given C. Okay, this means that probability of A and B given C can be calculated as probability of A given C into probability of B given C, and A is not depend on B and vice versa, opposite one and all. Okay, try to read this. Okay, you'll get much clarity. Despite this assumption of conditional independent, Navigates has proven to effect in certain applications such as test classification and all. So you can see five different scenarios I have taken. Let's say cap shape is equal to convex, cap shape surface, cap or surface smooth, cap color white, bruishes, yes, or the none. So by taking the permutation and combination of these five different things, I can express my Bayes theorem or Bayes theorem, the formula in this way. So C on the sky means you can put either convex or smooth or white, yes, no. So you can develop your formula altogether. Okay. So first I've started with the one feature, then I improvise the two feature. This something like multiple feature, like five different feature I'm taking. Okay, permutation and combination, different feature I'm taking. I'm trying to figure it out. Clear, guys? Any doubts so far? Any doubts so far?